Hello everyone, I'm Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. In this video today, I'm going to take a look at for loops, loop structures, and then our second example is going to look at file input and output. So the previous video took a look at while loops and do while loops, and so we're just going to finish up the deal here for C++, and we're going to look into for loops. So here is the problem that we're going to look at first here. So just kind of look it over for a minute or so, or pause it or whatever if you need to look at the code. I'm going to run it right now just to show you what the expected behavior is, and then I'm going to tinker with it a little. I'll ask a couple questions, answer my own questions, and then we'll modify this program slightly. So enter a positive integer. 8. I don't know. I put an 8. And it goes, the average of the first 8 positive integers is 4.5. So I'm presuming they mean if I add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, and I divide that by 8, I will get 4.5 as my result. So that's what this program does. And if I run this program and I put a negative value in, I get an error message, invalid input, integer must be positive. So that's where we're going with this, at least to start out. So let me just, okay, so a few things we can fix up here. I already kind of tinkered with it. If you're coming off my classwork and you have the example in front of you from the workbook, excuse me, then you've seen I've already modified a little bit of this. But again, these worksheets and a lot of authors seem to come from a C standard when it comes to setting up variables and putting everything at the front of the function or the front of their program, where that's just not the way we do things in the modern world. So right here, I'm only using number inside of this for loop. So I want to destroy that variable as quickly as I can. And so I'm going, instead of having it live and never die until it hits the closing curly brace of main, I can put it there inside of the for loop, and it will die when it hits that closing curly brace. So now I cannot go number equals 5. Oops, well, I can't do number equals 5. But even if I make it number equals 5, you'll see that it doesn't work because number is undefined. So we're working toward that. Let's see, what else can we do? I do need my total. We're going to be maintaining a total as we go through this. And actually, I can move this inside of the if statement because I'm only using total. I'm here to sum everything up and then to print everything out. And then when I hit this closing curly brace, total goes away. So I'm good with that. And then the mean, I'm only using that in this inside of here as well. And I'm going to change that to a double because there's no reason in the modern world to use, well, I say there's no reason. For right now, double is the way to go with things. Let me change the static cast and then we'll talk about it in a second. And the reason why we use double is because it gives us double precision in a float. I think in this world, moving on to almost 2022, I think we can worry about 4 extra bytes to store a number in memory, to have 4 bytes of memory, and then have 8 instead. I think we can do that. I think we can maintain it. So the value, the integer value has to stay up at the top because I'm getting that value from the user right here before we start. So there you go. I have some better scoping rules in place for this. Let's see, what else? Anything else I need to think about here? This guy here, number plus plus. It's always better for these kind of things to put the plus plus in front. It's one of those things where number plus plus can be slower than plus plus number. Compilers generally have optimized a lot of that out, but you never know. Maybe you're working on a student run. Maybe you're making your own compiler or whatnot, and you forgot, whatever. I mean, there's many different ways, many different compilers in the world, and sometimes people forget to implement certain features. So why don't you help the compiler out, right? So plus plus number, and then here total equals total plus number. Why write that out when you could just say total plus equals number? And let's see, total goes from int to double and then divided by value, cout. Okay, so I think we're in a good place here. I think I've modified enough here. So now we can tinker with and talk about questions related to the problem. And just to make sure here, let me run this one more time. and it succeeded, and I put an 8 and I get 4.5. Yep, okay, good. So now we're ready to move on to the second part. Let's have a little different discussion. So my first question is, what's the deal with this static cast? It looks ugly as you could ever imagine, which is true, but what is the reasoning behind this? So let me run this a third time here and say, okay, if I enter a positive integer, I say 8. I go, yep, the average of the first 8 is 4.5. Now, how about I get rid of it and see what happens? I try this again now, and you'd be like, okay, it runs again, and now I put 8 in, and it says the average of the first 8 positive integers is 4. And you're like, oh goodness, what's the deal with that? And that's because without casting from total here is an integer, and value is an integer, this is asking the compiler to do integer division. So yes, if that is the case, the floating point is going to be truncated from the result of this division, and even though it's being put into a double, you know, this is still an integer that comes out. This does not result in 4.5. This results in 4. And then here, I can even show you here. Let me run this one more time, put 8 in, and you can see here the total is 36. The value is 8, but the mean comes out as 4. But it's double 4, not int 4. So this does come out as 4, not 4.5. And so when this thing prints out, it's going to print out that. And so even with a double here, if I change it to int, obviously, and even if I put this back like this, I'm still going to get 4 out of the deal. It's crazy, right? So let's see, put 8 in, and now you can see total is 36, which will be cast to double, and then that's an 8, but it still comes out as 4. Even though this is now a floating point division, it still comes out as an integer because that has to be truncated from double to int to fit into the data type that we've set aside for it. So there's 2 parts to this. I need to have the data type set aside, and I need to cast. And of course, a cast takes an integer, or it takes the integer value total, and converts it from an integer into a double. It's only a temporary operation. You're not modifying total in any way. This is just setting up something that's only used right here in this division. So it takes quite a bit of processing. If you have to take my assembly language class, or if you've already taken assembly language, or you ever worked with floating point arithmetic, you end up losing your hair worse than I do sometimes, because it takes a lot of computations to turn an integer in binary into a floating point number in binary. And so this is not a free operation. So just be careful with your casts. But the reason why we don't just put double up here is because there's no reason to. Generally speaking, you always keep your data types realistic to the purposes of that you're using them, and if you ever need to use them for calculations basically after the fact, that's when you do the casting. You don't preemptively cast, because again, if I used a float here, we could get into trouble because there are plenty of numbers that can't be cast correctly to a floating point number, and we'll have an error if we try to do so. But double is good to go. Okay, so that is my first question. And the first thing to do is what happens with static cast and what integer division and all that stuff. So the next question is kind of coming down, another variation of the same theme here. What happens if I put in something like 2.99 in? If I put in a floating point number instead of an integer when it asks me for the integer, and it gives me something like this. The average of the first 2 positive integers is 1.5. And the reason that comes out that way, 2.99, what it comes down to 2, is the same thing we were talking about here. If I'm going to input an integer, or if I want an integer value and I'm coming in with a decimal point, it's going to truncate anything after the dot. So 2.99 just becomes 2. So it wouldn't matter if I put in 2.01 or anything up to 2.99, this thing would still get converted into a 2. And there's really no way around this. It's just the way it is. So that's a good indication there. So then the final part of this is to start modifying this slightly. And the question here is, or it wants me to modify the code. So instead of counting from like 1 to 8, if I put in 8, it wants to ask two questions. What is the low end and what is the high end? And it'll sum up all of those and tell me the mean. So like if I said if basically if you say give me the low end and I say 3, give me the high end and I say 9, then it will add 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 all together, and then that average will give me 6. Because there's 7 numbers there that are going to do that. So the goal here is to modify this program. So let's do it. Okay, so the first thing to do is the prompt. The prompts. Please enter the low end. As integer. As positive integer. And let me steal this. And go ahead and put that in. And now please enter the high end. And we're not going to do any data checking and go, oh, what happens if the high end is lower than the low end or whatever, right? You know, we're not really worried about that kind of stuff. And I'm going to call this low. I'm going to call this, and I'm going to call this high. This one I'm going to rename instead of doing it just typing in. And so it changes everywhere in my code, everywhere where that. Let's see, if low is greater than 0, or how about this? If low is greater than 0 and low is less than high. I guess we can put in some checks here, right? Or lower, or I guess less than or equal. I mean, it's one of those things, how do we want to check this thing out? But we want to make sure that both numbers are positive. And so if the low value is positive and low is less than or equal to the high value, then I guess we do get that. We get what we're looking for there. Both values will be positive, and the low value will be less than the high value. So I guess we can get away with it. Otherwise, it'll print out, hey, invalid input. Let's just try it out. Let's just see if it compiles first off. Yep, okay. So enter the low end. So if I put a -7 in and I put a -9 in, it goes invalid input. Everything must be positive. And let me just try this a few more times here. I go -8 and 9. It goes, nope, invalid. And what if I put then 9 and -8? It goes, nope, invalid input. So we could test this a little bit more, but I'm fairly confident that this one little if statement will do all the validations that we need to make sure that the low is less than high and everything's positive. Okay, so, excuse me. So now moving on to this part here. Everything else is done. We just got to worry about this stuff here. And the reason why I modified all of this down here is because we kind of have the high end already working for us. It already counts up from 1 to high. And realistically, what do I have to do? I think I just have to change number equals 1 to number equals low. And then as long as the number is less than or equal to high, plus, and I sum it up. And we might have to change this, but let's just try it out. Let's just see what happens. Sometimes you get lucky. I can see we're not going to get 100% lucky on this. I'm not going to do any other negative testing or anything, but how about 2 through 5? So 2 plus 3 plus 4 plus 5 should get me 3.5 as my, so because 3, 4, 2, 3, 4, 5. And that is not correct. 2.8 is never going to be the average. It's always going to be either a whole number, an integer, or a half, a 0.5, right? Because it's either going to be, you can divide by and get it. Okay, so coming back here, how many numbers? Instead of just going from 1 to 8, this just has to be changed from high minus low plus 1. Because if you look at something like this, 2, 3, 4, 5, how many numbers does that represent? It represents 4 numbers, which happens to be the low number, or I'm sorry, the high number. Subtract the low number. 5 minus 2 is 3. Add 1 and get 4. And that works for any string. 7 minus 2 is 5 plus 1. Hey, look at that. There's 6 numbers in front of you. Try it with anything, and you will find that is the case. Now I think we got it. So now if I do something like from 2 to 6, or 2, 3, 4, 5, I get my 3.5. Because there's 4 numbers, and the middle right there is 3 and 4, so the mean of that is 3.5. Oh, and the average of the first 5 positive integers. So I would have to change this high here. So I'm going to take this, I'm going to bring this out. Number of numbers, you know what that means, right? Equals high minus low plus 1. And I'm going to use that here, and I'm going to put this here. And I'm going to say the average of blah, blah. And I'm going to change this just slightly. And I'll say numbers from. And then I will say low to. And then I'll put high. Oops, high. And I'll put is here. I'll bring this down. Because again, you're never really meant to go this far out, like 100 characters. Even though everything's widescreen these days, you still want to kind of keep things kind of simple and small. So I'm going to bring this part down. So it's kind of consistent across here. And so now the average of however many numbers from low to high is that. So let's try that out now. And I think then we shall be done. So let me try what I was talking about earlier, 3 and 9. There should be 7 numbers. Say 3, 4, 5, 6, 7, 8, 9, 7 numbers. And then the average from 3 to 9 is 6. Because there's, 3, 4, 5, 6. 6 is the middle number of 7 of them, 3, 4, 5, 6. So one last thing we might want to do is just to kind of have some practice is to include IOmanip. And then down here, with the mean, this might be where I want to adjust the, so let me bring this down to one other line here. So this is where I could add fixed, and then I can add set precision to 2. I guess, well, should I do 2 or 1? That's up to you. I just have to learn how to spell precision. There I go. And there's my mean. I don't want to do that beforehand because I don't want to go the average of 7.00 numbers or anything like that, because that doesn't make any sense. These are integers. There's going to be an integer number of numbers, and then the low is going to be an integer, and the high is going to be an integer. Just the mean can be a floating point value. So if I do 3 to 9, there's my 6.00. And if I do from 2 to 5, there's my 3.50. So let's see, can I bring this down? There we go. It's all on one page. Yep, it's a little hard to read at the moment because the bold font kind of disappeared, but it's all good. It's all done. Okay, so that's all I wanted to do. That's this activity, at least this first part. So now we are ready to move on to the second part, which has to do with file input and file output. All right, so here is this example. And so my goal is to basically have an input file that comes in. We take the file or the data from the file, and we end up putting it into the quantity and the item price. And then on our end here in the program end, we're going to multiply that out and figure out the total bill. And I guess, yeah, from this side, the transaction.text, in a minute here, we're going to put the values 22 and 10.98 in there. We're going to multiply that together, and then once we have the result, what we want to do is print out to a whole other file, this bill.text file, something like this. The total bill is $241.56. So that's where we're going. That's the whole goal. Let me just fix this up a little bit. You know how I love to do this kind of stuff if you've been with me for other videos, or if you, well, nobody has seen me, no student has seen me in person for 1.5 years, which is a darn shame, but we're getting close, right? 5 to 12-year-olds are getting vaccinated in about a month, and then we can all move on back to, hopefully a little bit closer back to our normal day-to-day. But this guy, these two guys right here, there's no reason to, there's no real reason not to combine these into into one line of code here. The input file is going to be called transaction.text, and the output file is going to be called bill.text. And just before I erase this, just so I can remember the values. Yep, 22 and 1098. Okay, so there goes with that, and we'll fix up other things as we go. But one thing of note that there isn't, or two things of note that aren't in here, is that when you're done with a file, you have to close it. So I mean, you got to close your files as soon as you're done using them, and maybe we'll move this around. And that's because it's possible that this program might end and not actually spit out all the data to the appropriate file. When you go to print to a file, it would be the slowest thing ever if you printed each individual byte or however much, you know, a byte or a word or whatever to a file over and over and over again. Even with an SSD, you know, especially way back in the old days where there were spinning platters, physically spinning platters. Imagine how long it would take for you can only write 4 bytes on every spin of the platter, rather than basically spitting out a whole sector or a whole splotch of data. Splotch is my word of the day again. So there's a buffer that gets held, and then all the data gets put in there, and basically it spits out as much as it can at one time. And so that's, you know, that's kind of what is going on here. And if you forget to close the file, this makes sure that the buffer gets emptied into the file it's supposed to. And it is possible. You know, like I said, I've seen it before where you forget to close it, and then you don't even get anywhere near the same results. So you open a file, you use a file, you close a file. This is like, you know, way back in the day, Homer Simpson had to go to a parenting school and putting garbage in a garbage can. It's the same idea here. It's like open a file, use the file, close the file. And the only thing, there's an extra step that you might not think of, but what happens if that is broken? If data in dot bad fail equals true, then just for the sake of this, I'm going to print out input file, I guess, failure to open. And then put an end line. Oops, I guess I'm going to need my IO stream after all. All right, so there we go. So that's good. You open the file, or you set up the file, you make sure it opened so I can actually use it, and then I use it, and then I close it. And so the other thing I need to do also here, I don't normally recommend this, but for this example, why not exit? It's like a return, but it halts your program immediately, and it will return an error case. In this case, a 1, meaning that, the input file failed. And so again, this 1 doesn't really matter to us in the modern world, but if we were using this from like a command prompt and we're batching files together, this 1 very much matters. And so I can do the same thing here. First thing is to replace the 1 with a 2. So 1 would mean an input file failure, and 2 would mean an output file failure. And so data out, data in, data out. And so I set up 2 files called build.txt and transaction.txt inside of my project. So they're found at the same level of where the CPP file is. So I don't have to, you know, the question is always, where do these things get put, these files, when you use them? And so just for the sake of this, to say that at least with this Visual Studio, this compiler, these files are put at the same place where you find the CPP file in your project. So let's see what happens if I run this now. And nothing went wrong because those files exist in my project. It found them. It did not exit the program. It didn't do anything. It closed the file and it paused. But the second I do something like, if I just turn transaction into transaction, change a letter, you will see immediately here, what happened to the program, right? It ran, and it pretty much halted. Here, let's just put it in here. Let's put a breakpoint here, since you can see that it got in here and it actually printed out input file failure to open, because that file does not exist in my at that folder level. So good, I have this thing. I have everything working for the setup, for the open, the test for open, and then the close. And now everything else is just kind of using these files. And so what I want to do here, you can see the 22 and the 10.98. What I'm going to do here is I'm going to physically put them into my transaction.txt file right here with one space separating them and nothing else. And so space, in at least with C++, is the delimiter. I mean, it's pretty much every language. Space is the delimiter that says this string of characters is complete, and now let's begin another string of characters. And C++ at least is smart enough to look at this and go, hey, that's an integer, and hey, that's a float, when it figures out how to do this. So let me save this, make sure that gets saved. So there's my transaction.txt. And so now what I can do here is something interesting. Now that I have all this set up, using the file is exactly the same as what you would do for CIN and COUT. Because of the way the architecture of everything was set up, that basically you see how you use COUT here to spit out information to the stream. Now, if I wanted to do something like that with a file, it would have to be the output file, of course. But instead of doing cout, I could do data out. And instead of sending this information to the screen, it would send the information to this file stream. And that's the cool part. It even works for IO manip. It works for all of that stuff. It's architected exactly the same. And if you ever had any other kind of streams, and I'm kind of drawing a blank on other kinds, you either can stream to the screen or you can stream to a file. But what else is there? Why don't you leave me a comment if you know better, and I can be nice about it. And I'll definitely include you, and thank you for your submission to this video, for your help. So what I can do here is I can set up my int for quantity, I can set up my float for price, and I can say, hey, data in, why don't you put that first piece of information into quantity, because that's what I put in first, right? And when I go to my file, the quantity is first, and then the item price is next. And that should be a double. I always say that's, oops. So let's see what happens now. So now what happens here is this line of code, quantity is garbage, item price is garbage, but I run this line and now you can see quantity is 22, like we expected from our file, and then the price better be 1098, and it is, as a double. So 10.98 with a lot of zeros there. And so what happens is, when you do something like this, it says, hey, go look inside my file, get me the next, like a token is what we would call it here, and that gets me the 22, everything up to the space. And it says, okay, take that 22 and translate it into quantity, which is an int. And it does so, and there's my 22. And then now that this says, okay, get me the next splotch here, get me the next data, give me the next string of characters, hits the end of file, and now there's 10.98. And because of that, it puts that 10.98 into item price. And then that's all I tell it to do. And then down here, that I was saying earlier, is with this data in.close, I am done with that file. Close it out immediately. There's no reason to keep it. And the data out obviously should stay open. And maybe if you want to think of it this way, there's my input stage. This is going to be my calculation stage, and then down here is going to be my output stage, my IPO, my ICO, however you want to think of it, right? This is my input. Get the file from input. Here's, in a second here, we're going to calculate the total bill, and then we're going to open the file for the output and then spit it out. Okay, so float total bill, double total bill. You better believe it's a simple calculation, right? It's just quantity times item price. Okay, that's the calculation, right? All of this is for input. Here's my calculation, and now here we go with the output. So if this fails, do something, but otherwise, fill in the appropriate code. So I want to fill in, I want to set up. Do I have IO manip going? Yep, I have IO manip going. So I want to set up the IO manip here. I'm gonna have to put std : : in front of these things. No big deal. Show point, fixed, set precision, show point. I'll just go with what they have. And then fill in the output statement with this, so it looks like this. The total bill is, and then we can just use the total bill price here. So what do? This first part here, you don't want to do cout, because that will spit it out to the screen. This is not supposed to be for the screen. This is supposed to be for my output file. So this goes into data out. And just like for the output, and say we did the input where the chevrons here, the data goes into the variables. On this side of things, basically we spit out what we want to spit to the stream so that the arrows are going the opposite way. And so now here, to finish things up, I say data out. Okay, and I say the total bill is, and now I put my, instead of 241, I put total bill. And then I don't have to put any end line. I can if I want, but it doesn't make any sense. You generally don't want to put any white space at the end of your program or in a file. And so now, and then you close out immediately, and then you're done. So this file is empty right now with this input file. And if I did this right, there'll be no output to the screen because this is doing everything to the file. And you go there, press any key to continue. You're like, oh, this is scary. Okay. And then, but I open up bill.txt, and there I go. Total bill is 241.56. It opened the file, it put the data in correctly, and it closed it all down. Okay, so then what else might be left? You might want to put something here, basically, to also parrot it out to the screen. Just so you can kind of, if it matters to you. And so I can just change this like this, like that, and then I can just add a little something here, like output to file, put there, and then put an end line. So this will spit out the same information to the file as it will to the screen. And as I was saying before too, you generally want to close out that file as quickly as possible. Now you can see output to file, the total bill is 241.56. And for the output to the screen, you may consider probably putting an end line there at the end. And so there you go, output to file, the total bill is 241.56. And you could test this out if you want to just go ahead and just change this. I want 12 at $1.99. So it should be pretty close to $24, whatever it prints out. And there, output to file, the total bill is $23.88, which is correct. And there is the total bill is $23.88. So it's a really complicated program that does one multiplication, right? If you had your calculator, you'd be done 14 minutes ago, 15 minutes ago at this point. But getting used to files, it takes a little bit, especially if you're coming from Python, where they completely do file input and file handling different than many other languages. And it's for good reason, because Python is used for data manipulation and things like that, and so it's perfectly legitimate for its modern day uses. But it's learned from languages like C++. This is as raw as you get. You're looking at a file and you're getting data and you're just trusting. At least for now, we're not doing anything with error checking or anything like that. So we're just testing and trusting the data as it comes in, and we're just doing some calculations and spitting stuff out. Yeah, definitely no input validation when it comes from this file to make sure that numbers are coming in and we're not completely jamming up the works here. So let me see, can I get this all on one page without it looking ridiculous? Oh, I did it, good. So there we go. Here's our input phase. Here's our calculation phase, one line, and here's our output, and then followed up with our cleanup. So that covers everything I wanted to do for files, and then previously also for loops. So as always, if I misspoke, which is very easy that I can do that, or if you have any questions or concerns or anything at all, please comment below here on YouTube, or you can get a hold of me at swardb@cod.edu. So thanks for sticking it out with me as always. So this is the end of chapter 5 stuff. So now we're moving on into functions. So setting up a function, setting up parameters, setting up return types, using those functions. We've been doing this already. We've been using functions and actually objects here. This IF stream is an object. So, we're using all these things. Now is the time we're going to start learning, how to create our own custom functions, arrays, and object-oriented programming is going to finish up this course. All right, thanks for sticking out with me. Have a great day, everybody. Hope to see you in another video. Take care. See you then.